Have you ever wondered what keeps an airplane from soaring into the skies at unimaginable speeds? The answer lies in a concept known as forza de resistenza la inintare. This term, hailing from the world of aeronautics, defines the air resistance that manifests on an airplane as it moves relatively through the air. It's a force that opposes movement and acts parallel to and in the same direction as the relative air current. Think of it as the unseen adversary of flight at high speeds. Every aspect of an airplane's design, from the alignment of its form, the quality of its construction finish, to the polishing of its surfaces, is meticulously crafted to reduce this braking force. So the key to efficient flight lies in overcoming forza de resistenza la inintare, and the primary purpose of the propulsion group is to defeat this forward resistance. Now, let's dive deeper into understanding the total forward resistance. This is essentially the sum of all aerodynamic forces that act parallel to and against the direction of flight. Think of it as the total resistance to an aircraft's movement as it navigates through the air. It's the culmination of different braking forces that act on the aircraft. A convenient way to study these braking forces is to divide them into two basic groups. The first group is those forces associated with the production of lift, which are known as induced forward resistance. The second group consists of those forces not directly associated with increasing lift. These are known as parasite forward resistance, which includes form resistance, friction resistance, and interference resistance. Thus, the total forward resistance is a combination of both induced and parasite forward resistance. Let's focus on one of these forces, the parasite forward resistance. This is a term that encompasses three different types of resistance: form resistance, friction resistance, and interference resistance. Now let's talk about friction resistance. This is generated by the friction forces between an object and the air through which it moves. Imagine the entire surface of an aircraft moving through the air. Every inch of that surface is generating friction resistance. Now, the value of this surface friction resistance isn't constant. It can change depending on a couple of factors. Firstly, the size of the aircraft's surface. Naturally, a bigger surface will generate more friction. Secondly, the nature of air separation near the surface plays a role. If the layer of separation is turbulent, it mixes more with the surrounding air, leading to higher forward resistance. So, factors like the size of the aircraft and the nature of air separation play a significant role in determining the parasite forward resistance. We've learned quite a bit about forza de resistenza la inintare today. This aeronautical term, which defines the air resistance that an aircraft experiences while moving relative to the air, is a key player in aviation. It's like the villain of our story, opposing the aircraft's motion and acting parallel and in the same direction as the relative air current. We delved into the concept of total forward resistance, which is essentially the sum of all aerodynamic forces acting parallel and opposite to the direction of flight. We also explored parasite forward resistance, a collection of forces not directly associated with lift production. These include form resistance, friction resistance, and interference resistance. The next time you're on a flight, you'll know a bit more about the science that's keeping your airplane at its cruising speed. Remember, every bit of air resistance matters in the world of aviation.